Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Konrad.
Welcome back to another episode of the Reliability Matters podcast. I'm Mike Konrad. For those of you who are keeping track, this is episode number 118. The subjects of Industry 4.0 and big data have been widely discussed on this podcast. What is Industry 4.0? What data is our industry collecting? And perhaps more importantly, how can we sift through all of that data to make it useful and actionable? To help answer these and other data-related questions, I invited Ryan Gamble, CEO and founder of Intraratio, onto this episode. Intraratio Corporation is a company that provides on-premise and cloud hybrid software with platforms to track, manage, control, and automate the manufacture of advanced electronics. Intraratio serves the semiconductor, SMT, space and military, medical device, and EV markets. Ryan earned a dual electrical and computer engineering degree and spent many years in the semiconductor industry. He's responsible for improving product manufacturing and testing of commercial and space and military products. He's responsible for improving product manufacturing and testing of commercial as well as space and military product lines, including multi-core DSP, RF, and silicon photonic devices. During this period, he developed software systems to automate and manage quality and reliability of complex electronics, extending this to hyperscale web-based platforms that interconnect factories globally. His passion is working with all levels to identify and recommend solutions to business problems based on a deep technical understanding of operational processes and product complexities. Without any further ado, it's my pleasure to welcome Ryan Gamble to the show. Hi, Ryan.
Thank you so much. Yeah, real pleasure to be here and have the opportunity to share what industry knowledge, experiences, and guidance I can on this very pertinent topic. Thank you.
Yeah, my pleasure, and thank you for agreeing to do this as well. I think it is a topical subject for sure, and every time I watch the news or catch up on current events some way, I hear the term big data, and it's never in a complimentary context. It's always, big data is spying on us, and big data. It's all kind of negative news. However, I suppose, like many other things, it's all contextual, right? It's what we do with that data. If it's used for nefarious purposes, like maybe some social media platforms use it for, or at least allegedly use it for, that could be quite problematic. But I think we live in an exciting time because finally the technology has allowed us not only to capture it, but to store it. We've been able to capture it for a long time. Storing was another problem because storage used to be expensive. Many years ago, probably in the late 80s, maybe early 90s, I think it was the late 80s, I went to see a customer and they made memory chips. That's all they did, is they made memory chips. And we could get into the facility, no problem. To leave, we had to go through metal detectors. And they had armed guards running you through metal detectors. It was harder to leave that building than it was to get on an airplane today. And the reason was memory was so expensive that vendors, employees, anyone that went into the building could make a small fortune by grabbing a fistful, putting them in their pocket, and leaving. It was that expensive. And these were, 16 meg memory cards, right? These were nothing compared to what we have today.
We work in this space. It's pretty amazing what you can store in a memory card these days.
Yeah. Well, I do a lot of content creation like this and other things. So video still takes a lot of content, relatively speaking. So I have my nice MacBook Pro, which is, this thin and, this big. And then I have something the size of a shoebox, which is a 12 terabyte external hard drive. And that sounds like, in your world, that's not a lot of data. In my world, that's a lot of data. It's like a 10-pound shoebox that I have to constantly use because my my 1 terabyte hard drive, SSD hard drive in my laptop is nowhere near enough. I'll do 3 or 4 episodes and it's full, right? So I have to export everything to an external hard drive. Now, in your world, that technology advancement, that evolution in memory storage has really made your world possible. Because now not only can we grab it, we don't have to be too careful about what we grab. We can just grab everything and then decide later,
And that comes back to burness later. So it's interesting, there's a balance in that, and we'll kind of talk about that.
Hence the term big data, right? We're able to collect a big amount of data, a large amount of data. So before we dive into this whole data thing, tell me a little bit about Intraratio, the company you founded and that you are CEO of.
Okay, so we're a company that's born out of, I'm going to quote a former VP Ops Qualcomm. He said it's basically, to him, was a company born out of product engineering DNA, and it really fits on that. Basically, developed solutions to solve problems when I was a product and test engineer, being responsible for some of the largest system on chip products out there in the market, and the reliability issues we're having. At one point I was responsible for a product line that was behind most of the advanced internet routers in the early 2000s. So it was deployed across Cisco, Lucent, Alcatel, Nortel, all their infrastructure. So, voice over IP was coming on board. And that massive complexity, you got 1 billion transistors. Now it's being placed on a board with billions of other transistor-based devices, and the complexity. So the company was really born out of that. How do you track all that, collect all that data, and analyze it, and be able to identify quality issues before they happen? And then also, very importantly, how do you identify the root cause of quality issues when they have happened, and do it very quickly? So that progression of my career, about 20 years as an electronics semiconductor engineer, working in back-end semi, sometimes in the fab, but mostly back-end semi, all the way to final electronic system products. I developed software platforms that would interconnect and grab the data, and then also connect to the suppliers, because product would go out the door to a supplier for some other sub-assembly and come back in. How do you track that? So in a way, we're kind of ahead of the curve in terms of tying in the whole supply chain. And as I was creating these solutions, eventually it was time to commercialize it and spin off as a formal enterprise. So that's sort of where it started, late 1999, all the way through to finally 2010, spun myself off as a company, commercialized the solutions.
Sure.
And they were really built around solving the engineering process, the deep intractable traceability issues that we are continuing to have today. So that's sort of the background there on the company.
I always like talking to entrepreneurs, whether you consider yourself an entrepreneur or not. You are, obviously, because you left the so-called security of a paycheck, a bit of a false security, but a security nonetheless, and dove off the into the deep end of the cold pool and decided to do this on your own, and that. That's certainly risky, but there's usually an underlying reason for it. Now, there are many reasons people get into business or start a business. One might be they see something on the market and they go, yeah, I want a piece of that, and we can do that. Or they see an absence of something in the market, or they see the opportunity to take something that's in the market and make it better. That was my case. I didn't invent the technology we had. I just optimized it and made it sexy to engineer sexy, and more useful. So, what do you think? You fall into one of those 3 categories? Did you see something that wasn't being done well, or not at all, or pile on, or what was the context of that?
That's an awesome question. Yeah, and I think it's kind of a bit of all of them. And it's great, you've been down this path as well. So, lots of understanding on this. There were solutions I was working with. Data was being collected from testers. There was data being collected from work instructions, or like tracking when product moved through a step. The wafer maps being pushed into machines. They were stored in different places. And what you had was these different solutions everywhere. that I was working with, and none of them talked to each other. So if you wanted to understand the trace, what happened to a product, how many steps, I'd have to go over to the terminal on an old MES system called Promise. I don't know if you remember that name.
No.
But man, it's like dark screen lettering, you're typing at a command line prompt, there's no graphics. And you're like, where did these wafers go?
The old monochrome green on black screens, right?
Exactly. Yeah.
I do remember
this
that.
This is early 2000s too.
Oh, wow.
This is the web's already out, but you've seen inside factories, they're running on software that's 10, 20 years old. So different systems. And then, say try and pull data. I couldn't download data. Sometimes I literally just have to transcribe what was there. So that's a digital problem. How do I connect that digitally? Then I go over the tester data database, and I'm trying to pull it out. And this tool is written in a specific way, and it's very clunky, and I can't get to the raw data. And I find problems in that tester data as well. So you tested a product 4 times, right? But there's 8 data sets in there because it's not flagging duplicate data. So now I'm like putting on my, trying to figure out, am I looking at a real yield or not? I mean, these problems that tie me up for 90% of my day. What is the data I'm trying to get? How do I clean it up? Some of the data doesn't even have the part number on it. What wafer did it come from? Because somebody didn't bind that in or enter it correctly on the production floor. So these systems are all siloed, and I'm working with this, and this is like a $1.4 billion company I'm working at the time. So they got money. They've thrown money at all these tools, but none of them all interconnect. So I'm the guy running around the campus. So getting to the thing, what I did was I said, you know what, you can collect all this in a centralized place and you could tag it and contextualize it. So I was finding the problems with existing solutions, how to fix that. But then the other one was I'm constantly grinding through analytics. I can write a nice script, because luckily with a double E degree and then a computer science degree as well, commensurate, helped me be pretty good on software. So I would start automating my job. I'd say, you know what, I wrote an algorithm that would just run through every data set and cross-correlate it against everything else. And it may take 20 hours. But after that 20 hours, holy cow, the insights that were just coming out.
Yeah, and you could do something more productive during that 20 hours, right? It's a good investment.
Honestly, absolutely. Actually, and I took a lot of time to meditate. I would actually go and exercise a little bit more. I actually had a healthier lifestyle, and I was solving some really complex problems. I didn't understand how certain designs were in a chip, how the transistor was working on some very advanced designs. But just having the data and being able to cross-correlate against itself, I would find insights and correlations there, and I'd feed it back to design. And many times they were like, how did you find that? You just solved an issue we've had on design in terms of trying to get to, a certain frequency band. And then they talk to me as if I understood the actual circuit. I'm like, I'm sorry, I haven't even seen the actual design. Now I need to exit the room. Thank you. Right.
Time to go.
Yeah. So it was that kind of experience, dealing with these siloed systems that had all sorts of problems that couldn't deal with the real world nature of data. They pull it in, create a wafer map. There you go. Hey, but at the end of the day, everybody was trying to figure out whether they're looking at true yield or not and what was going on. So that was the one problem. And then where was the real motivation, the pain to create a solution, sort of start on that entrepreneurial path was we had a reliability issue. So same company, a couple of years later, I'm playing around with my software and I'm kind of automating it. We have a reliability issue. It's a central side modem chipset. I mentioned, that being responsible for this device that was in Alcatel, Lucent, Cisco, everything, all advanced routers around the world pretty well. And we couldn't solve it for 6 weeks. And the customer designed us out completely. One of our key customers, basically.
Wow.
The customer is actually mine now, Cisco, but they designed, where I was working for, they designed the chip out in 6 weeks. That was a $70 million revenue loss. So now there's acts cutting the jobs, there's carnage, and turns out I'm the only guy in this massive company that's actually been trying to piece everything together. So I got my little databases I'm playing with, and an army of consultants lands on me, and I see how they methodically start walking through connecting the dots. And they kind of outline that path to how to better connect the dots, from device design to machine data to actual tester data, fab data, tie together. And ultimately, those data sets that I had that I was collecting helped them identify the root cause. And we got through that, but didn't recover the revenue, unfortunately. So
Well,
so there were layoffs.
you secured your job. You were the last person they could fire, right? Because you had all the secrets.
It's but as you said, the having a paycheck is not the thing to hang your hat on. There were 9 layoff sessions for various market reasons after that.
Yeah.
Company got shaved into pieces. Anyway, we've all been through that crazy ride up and down. But yeah, so that's really the story. And then piecing it together. The other thing is you work with some very insightful people that kind of give you a little guidance. And so I have to pay respects to having a great manager at the time, and he just said, keep going, keep doing what you're doing. He bought software licenses before I even thought about buying the software to help innovate a bit better. So, and then when I moved to another company after that, now I was armed. I went in and I said, this is my IP. This is what I bring to the table. Let's make sure I own it. And I'm going to deliver on some things internally here. And then I had some really great people to work with there that fostered that innovation as well.
That's great.
And so that's.
I loved your comment about how you took the time you saved after you invested time writing code to analyze the code and sort through it. You use that extra time you saved to meditate and exercise. It's not very often one can say writing code is good for your health, but in this case, it definitely was, right? Let's define some common terms. Most of my audience is within our space here, the EMS space, but just in case, let's just start with the beginner's mindset. Frequently, we talk about Industry 4.0, and that I'm thinking might have different connotations to different people. It could be a little bit contextual, or it might just have might be the result of a marketing campaign some manufacturer put out. It's like the term AI, artificial intelligence. I can't tell you how many consumer devices claim to have AI. Toothbrush with AI. It's like, no, it doesn't have AI. That's just they've taken a legitimate technical term and they've bastardized it and turned it into a marketing term. So let's talk about Industry 4.0 for a moment. What is Industry 4.0? And does your definition and understanding of Industry 4.0 differ in any way from the conventional interpretation of that phrase?
I think definitely aligned with what it is. If I think about how it originally came out of sort of more the German groups, Industry 4.0, sort of a European coined thing back in the day. It's really about leveraging data in a way that you can automate actions and insights, be that transferring of data through a central repository and then processing it back to a machine to instruct the machine. Basically, just leveraging data to start to integrate more and more automation where the vision at the end of the day is the production line sort of runs itself. I think that's a little bit fluffy, honestly, just the nature of things. But that's the definition to me. I see it, and what I've bound to is that just leveraging data and applying some good analytics tools. AI, it's machine learning. They're not applying anything beyond that. And at the end of the day, when you look at machine learning AI, it's really just a whole statistical regression, just looping on itself. Walking down a tree of data until it finds that one little thing. But it's really leveraging all those to create an actionable sequence of events through the manufacturing. And now it extends out to the supply chain side. And I think that's the very nebulous side of it, is what does Industry 4.0 mean in terms of supply chain interconnectivity? And my definition is just interconnecting these factories just with just some core product traceability data that can create those actionable insights. Realistic Industry 4.0. It's just simple contextual data shared between companies all the way down that can be now leveraged back into your factory floor to create these feedback loops of actionable insights.
I like that term, realistic Industry 4.0. That's much more qualified than just Industry 4.0. Because as I said earlier, that's kind of become a buzzword. How about the terms CFX and SMEMA and Hermes and all of that? Let's contextualize those terms as well.
Yeah, those are protocols, so their data, it's really, at the end of the day, it's a specification of like how to write data into some electronic format and then what those blocks mean and then how they should be interpreted and what actions should result from that. So basically protocols for machine-to-machine communication, in essence, just to specify a signal of an event and pass on that data between systems. Sort of my general definition of that.
Right. It's almost like a programming language. It's like you said, a protocol, right? One machine may not speak the other protocol, in which case it's just signals that it doesn't know what to do with. So, so the early days of communication between various pieces of equipment. Equipment have had the capabilities of talking to each other for many years, maybe more in an analog fashion than a digital fashion. For example, an assembly could leave one machine, head toward another machine, and a signal, probably an analog signal, just an open close, would just send a signal to the next machine saying, hey, this is coming, right? And it would turn on something. That was, very basic machine-to-machine communication. Today, instead of limiting communication to a simple analog signal, we've added data to what is being sent and collected. It's become digitized as opposed to just on-off, open-close. And the explosion of that data and storage technology over the past several years has increased our ability to collect data points, dozens, perhaps hundreds from each machine, cumulatively millions of data points from all these machines, probably billions in your world of individual data points. And that's led to this stockpile of, quote, big data. And perhaps this question is at least as big as big data itself. How does one convert all of that data or discern all of that data into more useful and actionable data? So we've come to the point where we can collect all this stuff. Who's the guardian at the gate to determine, we don't care if a light bulb went out on a machine. That doesn't really matter for this particular application, but something that would result in an escape or a component being placed backwards or a machine shutting down, something. Who's the arbiter of all of that big data? Does it start with you? Does it start with your customer? Does it start with the industry? Explain that process to me in 4 hours or less.
Yeah. Certain vendors, certain software companies, man, they'll talk your ear off on this. For me, it's really straightforward. And so I just start with big data. Yeah, it's a nebulous term in many cases, but originally it applies to unstructured data. So just for the history of the term, really grabbing every and all data and just throwing it into a bucket somewhere, some big storage container, because storage is cheap now. And then afterwards, you can now go through and write some software to mine through it. So it goes back to sort of that example I talked about back in the day where I wrote a little algorithm just to cross-correlate different data sets and stuff like that. And then you get insights, so that's sort of where it is. I think in manufacturing, big data is different. It needs to be structured. There are solutions out there with competitors, that do it unstructured. And then afterwards, they're like, okay, customer, what type of insights do you want to see? Now it becomes a big fishing expedition. You're going to pay per report. And, you can kind of sense my disdain in my voice on that.
Well, and a lot of time in your world, I'm sure this is especially true. I know in my world it's true. Customers don't know what they don't know. Yeah. So if you ask the customer, what do they want to know? They may have some tunnel vision, right? And limit out some other practical data, useful data, actionable data that they didn't even consider. Maybe they didn't even know it was being collected, right?
Yeah, that's a big a risk in the approach. So how to remove that risk is basically look at data as needs to be in context. If I'm going to have data come off a machine, how do I know that which product, what board serial, what operator was on there, what work shift time, what machine ID, what were the process settings? Just as a minimum, what was the result? Did it give you a known good, a known pass? Just that key stuff, that can be put into a really nice table structure. And then how to get that in is sort of the real key thing. How do you get it in context? If you're just grabbing that data and throwing it up in the cloud, later on, you got to come around, you got to figure out how to contextualize it. So what I call it is data binding. So solving the big data problem in manufacturing, because there's so much data, is really bind it to the right context, tag it correctly right at the start. Then you don't lose that in the future. You're like, oh man, I wish we could have looked at it like this. Right. You're good. You've tagged it. You know what work shift, what time, what machine ID, where it happened. Now, systems don't talk to each other very well for most on the manufacturing floor. You have one machine talking to another. Each machine will dump data in a different format. So you need to, when you look at big data, you got to break it down to, okay, what are my sources of data? How do I contextualize it? And what type of system can I use to collect it and contextualize it for me? And do it in a decent amount of time. We're in a really great point in technology where most networks can run at gigabit now, gigabit Ethernet. You can upgrade your router on your production floor, your switch, and you can start pushing, 100 meg per second at least. You can grab that data very quickly. You can stick a low-cost server at the end of it and start to hoover it in. And you can just copy that out to the cloud just in case something happens to that server. You can do that in real time. You can actually set that kind of system up in a day if you just plan it out.
Yeah, I have a gigabit internet provider at my home. It's all fiber, and I'm at 1 gig, right? And now they're offering me 2 gig. I don't need 2 gig, but you're right. It's become, speed, not just is memory cheap now, speed is cheap.
Yeah, so now you can contextualize data and store it quickly. You don't have to grab it and throw it up in the cloud and, come back later and figure out what you're going to do with it.
Right.
So that's sort of, for me, it's like you can contextualize big data. Manufacturing needs to be stored. Data needs to be stored as coming off in a contextual structure. And you can grow databases really big. As you're talking about, you've got your multi-terabyte box. It's the technology, especially the open source side of it, is amazing. Google, Facebook, Amazon, they don't exist in their form today if it wasn't for some key open source technology stacks. One of them being MySQL. In the back of Amazon's big RDS database technology, the logs spit out in the old MySQL mode. You can see it. Wow. They use MySQL and scale it up. So companies today have access to great tools. You use to collect this and contextualize it, but you need experts. You need an expert who understands machine data, has an understanding what the machines are doing, has an understanding of process, supplier, to help set it up to tag it. But yeah, you've got fast networks now. You can move this data in real time. You can store it in real time. You can make it actionable in near real time. And I say near real time, God, say actionable within about 100 to 300 milliseconds. Which
that
is
long?
Yeah.
I guess if you were a stock trader, that would be too long, right? But in this world, that's awfully fast.
Yeah. Well, I tell you, companies like robotic assembly systems like Harmontronics, that does 23 operations of a whole assembly, and each one's transacted, against Intraratio's software platform. We have to respond our software platform within about 100 to 200 milliseconds. Otherwise, the next operation is going to jam up. So you have these interesting things that happen when you're reading data in real time, you're creating a feedback. So doing this industry 4.0 approach, but anyway, kind of going off a little bit, but yeah, making the data contextual makes it immediately actionable, and that's powerful. And then big data is not big data anymore. It's not unwieldy. Now it's usable,
Right.
So
it's useful data.
Yeah.
So speaking of useful data, how can useful data influence process optimization? I interviewed someone from a medium-sized EMS company a couple years ago, and the platform he stood on quite firmly was that an American contract manufacturer can be just as competitive as an offshore contract manufacturer with the right amount of optimization and efficiency. If it's all about labor dollars, then you're not efficient enough. That was his point. And I've had some people say that's a little Pollyannish, but the point I totally get is, we can certainly make our processes more efficient through optimization. How can, the early days of communication between equipment, as I said earlier, was, telling a machine to turn on, something's coming. And it was very basic. It was very practical. How now can the use of data markedly increase the level of optimization and therefore efficiency, and reduce operating costs, and make embracers of this technology more competitive?
Yeah, I love answering this one.
I queued you up, right? Good.
The ROI, where it sits, 100% agree. I look at one example is look at Germany, the Mittelstand, right? All these little mom and pop factories, and how they started to automate in these small factories, and they made themselves hugely competitive, and they start to create products that were very bleeding edge technologies, that the other low cost manufacturing centers couldn't replicate, very quickly. Now they're catching up. China's catching up, but Germany really moved it. So it's this approach of automation. Now data brings that too now in the world, and we absolutely can equalize it. The labor thing does not become the issue. Just when you're automating, where our costs are really sitting is on the engineering side. You can only squeeze labor so low, right? You need these people, right, but you can do a lot more when they actually have all the information they need. So it's kind of this. So basically, data, you're cutting out with good data contextual, you're cutting out 90 to 95% of engineering time spent a day that's wasted. I talked about that in 2003 when I had the reliability problem. That was my day. It was 90 to 95%. Just, do I trust the data? Cleaning it, loading it, doing this. As soon as it's contextual and it's right there, your decisions are supported, you're guided in the right direction. And so now you're improving it. We have one of our customers actually documented that for us on a deployment on the data. They proved it. They had a 94.6% improvement on their engineering time. And those are expensive dollars.
Right.
Now you add that to management. Management's running up and down the floor trying to figure out, where are my parts? Am I going to deliver on time? My ERP is kind of telling me this, and somebody updated this spreadsheet, and they're in mixed mode. When you pull all the data together, you centralize it, you contextualize it, that gets solved instantly. So the competitive element is huge. And I know when dealing with Asian partners, I quickly learned as an engineer, we try and launch a product over there, and I'd get somebody junior, and I'd be working with them, and I train them out. The next thing, they'd disappear, and now they're in sales trying to sell to the next company. So we were training them, and that's fine, but they could just throw people at it constantly, and that's the thing. And they still have a sea of people. I know one CM, they have 50 people that just sit there and fill out spreadsheets all day, and we could remove that entire group with one software license installed. We do that here in this market. Yeah, we can completely level the playing field easily. We're reducing that engineering cost, and every one of the customers that I've seen, companies that have improved their processes, improved their data capability, have grown. We've got a customer that's grown 4x in 2 years. They're gobbling up automotive product lines. They weren't really firmly in the automotive sector before for electronics. So I've seen the proof. It's there. Hugely competitive, and that's the future. Kind of mimic what Germany did in terms of automation. Now we have automation. Let's take it to the next level. I'll call it data automation. And that's self-reinforcing, and it just brings massive growth. So,
and I would think that there are certain industries, auto being one of them, that really values data. I would think that because National Transportation Safety Board, NTSB, can can order recalls. They have to know if a part goes bad, they have to know who made the part, which parts those cars went on, what the VIN numbers were. They need to know what owners to notify. The same with aviation and other high rel applications. I'm sure they expect their vendors to have some form of data collection that can help with traceability, probably efficiency too, knowing the auto industry, but definitely for traceability. I would imagine that those are modern requirements just to be able to sell to certain industries.
Yeah, very much so. Yeah, they have to get the DPPM level so low. You know, I remember having a chat with somebody and I just said, you know, what you're dealing with the automotive market is you're talking billion points of failure in a car. It's not like the few thousand, it's now billions of points of failure. And then I had a chat with somebody who was from Accenture. Actually, CTO of Accenture gave a chat at a Global Semiconductor Alliance presentation a couple years ago, and basically said, you know, every hour there's an Audi coming off the line that is destined to go back into the repair shop because of electronics.
Yeah.
You know, and yeah, that's just accelerated. And we've seen some EV companies like Tesla. They're brilliant. Their supply chain, show me the data. You know, This is how they really started to move the needle. You know, the rest of the auto industry does that too, but I think, it was interesting to see how they tripped up with the semiconductor thing. They're just, you know, that's just taken over so much computing power on a car. You know, they didn't have the supply chains lined up properly. You know, the reliability issues they ran into. You know, data solves that. So it's become critical, absolutely. You know, and for a single line, small SMT shop, I mean, if you have a traceability system that's automated, you can show that data. You can now, the customers you can capture for the margins. It's great. Just brings so much prowess because the demand is there on these more sophisticated end OEMs.
Yeah, you mentioned Tesla. I've said this on the show before. I think one of the differences between Tesla and the conventional companies is Tesla started out as a tech company with the aim of building cars. The traditional companies are car building companies with the hope to add more tech. They just came from 180-degree different angles.
Oh.
And I think when you're a tech company, the downside of being a tech company building cars is your fit and finish isn't all that great, right? The quarter panels don't quite line up. You have wide gaps between panels, where the traditional car companies, they got that down, 30 years ago. But your tech is amazing. And, Tesla has the best tech of any car company. I look at Volkswagen, not to throw them under a bus, but, they have with their i4 or whatever they call it, model, tons of tech issues, buggy, super buggy. But they come into this fairly late in the game. They didn't start as tech. They started, building VWs with no electronics except maybe the radio. Everything else was electrical. So it's just a different mindset. You mentioned earlier that you gave an example of how one software license could solve one particular problem, right? Is there a I don't want to get into your pricing models, nor do you, I'm sure. But is there a significant barrier to entry for embracing a company like yours or other of your competitors? Is it a huge investment? Is it a fairly rapid ROI? What are your customers' experiences?
Yeah, it depends on the solution provider. The market has a number of solutions out there. And I'm a different company, right? I come from the engineering side, and the number one thing was it deploys. It doesn't need you to hire anybody to support. IT loves it because it just comes in and drops in existing infrastructure and just leverages what's existing inside your factory walls, right? Which is pretty sophisticated today. You've got 100 megabit per second network at least. You can put a switch, a router. You can use cloud services to connect in your factory. So the barriers to entry depend on what kind of solution you're going into. I'm pretty opinionated in the market now. We've been running for about 12 years. And when I came out of more the sophisticated side, we deployed in silicon photonics. So we're dealing with like traceability of a chip on the endpoint of fabs, all the fab data coming out, how it gets split up. Then they place chips on that chip, plus a laser, MEMS, plus they program it with firmware, software, put on a PCBA. You have to have that track. That goes out to a CM, Amcor, or ASE. How well did they do it? Do they test it, get their data, come back in, full traceability? Now you go plug that thing in a supercomputing cluster or in a Amazon data center, and your email better be working. Your
right.
shopping cart better fire off when I'm ordering my stuff so I get it in one day. That reliability. So that's where we came out of, and being able to solve that was really straightforward for me because focusing on ease of deployment, ease of integration, protocol agnostic. Don't force vendors, machines to change how they generate data just because your software is clunky, right?
Right.
Your software, the MES and the IoT system should adapt to each different machine and protocol. It should be the universal translate. So that approach completely squashes barriers to entry. So isn't the final example. So we've been able to deploy into NPI, bleeding edge startups doing printable wearable batteries into full on Volkswagen, Audi automotive lines. One of our first deployments was in a GM autonomous vehicle line, 3,000 BOM components, high reliability, running it through a fully automated line. So going from almost a mom and pop shop startup all the way to high volume global connected factory, same stack. The barriers to entry have dropped working with a vendor like us. And there's other vendors that are similar to us, which is great, seeing the market move. Now, if you go with one of the big names, it's going to be a time and materials build out. They're going to customize everything. And the question is, why? Why do you have to customize? I'm going to buy a Siemens system. Why do you have to customize it when I'm an SMT line and you've got hundreds of SMT lines deployed? Because the model is backwards. It's time and materials. They give you a cheap license, and now we're going to nail you for SOWs and nail you for contracted support and service hours, because we can funnel that out to outside the country and get a massive margin on these per hour dollars. And that's our fee, customization. So you ask those questions. When you ask those questions, I think an end customer, the manufacturer, when they ask the questions, they will align with the right vendor, and the barriers to entry will start to disappear to the tune of 12 weeks. We've done deployments as fast as 12 weeks. And I can give you one of the craziest examples. I didn't believe we would have done anything as good as we did, and I'm not going to put it on me. This is my team. I've had some great engineers working with me. Really clever guys and gals figuring it out. But we deployed to a factory line. I just tell the audience just how the barriers of entry can disappear with the right solution. We deployed to a silicon photonics customer in the Boston area, wired in their feeds to TSMC, Global Foundries, a site in Canada, a lead site for contract manufacturing, as well as another site in New Jersey. All their machines, testers, data were flowing through the network, being passed by FTP, sometimes direct across the web, all secure. And we connected up the whole factory line, or supply chain line, and now they can see where a wafer is at any point in time, where it's been diced, where it's assembled. We don't even know what they look like. We actually never left our offices in San Diego. We just remoted into their existing IT infrastructure, which they set up, basic servers, and started to connect that up. So the conclusion is the right vendor with the right technology has removed the barriers to entry. You can take a single SMT line right now and turn it into a lights out factory floor. And you don't have to force any machine to change its protocol or its on it, so
right.
Yeah.
Yeah, that's quite promising. You talk about the right vendor. Let's talk about that for a moment. If I'm looking for a vendor like yours, like your company or the others, what types of questions should I be asking you? I'm like, okay, Ryan, here's what I think I need. How do I go about vetting a provider and explaining what I think my needs are? Give some advice to people who have not yet exploited all of that data all of their various machines are collecting, and they know they need to, or maybe they want to. What kind of smart buyer? What would you define a smart buyer as, or a savvy buyer?
Yeah, that's such a good question. It's really asking them, really understanding what their whole model is, what they can guarantee. I think, what they can really, if they can put their money where their mouth is. They say, one of the key ones is always ask what has to be customized. Like, here's my production. So, and vet that they really understand what you're doing, and then roll up your sleeves with them, and say, okay, at all these stages, this is what I need to track, and understand what they have to customize and question why. Why do you have to customize this? I think that's one of the first things, is just have them put their money where the mouth is, see what they can guarantee in the deliverables, see what they price out, but then dive in and start asking about all the customization. Okay, so this is delivered up front, great. Okay, this needs customization. Why? I think in today's market now, there's enough companies like Intraratio out there. We know how Yamaha, Fuji, or Panasonic dumps data. We know AXI, AOI. We better be able to speak to it, and we better have a way to catalog it in real time to give you, analytics results. So you have to dive in at each one of these key stages and really start to question the why are you customizing. And now you'll start to unearth all these other costs. You'll start to see, let me get my field application engineer over here, and now they drag out the conversation too. So it's also that time. You look at how much it's taking for them to answer those questions. It's kind of vet how good a vendor they are.
You brought up something there. Your company, your team knows, a Heller oven, what they collect, a Fuji pick and place, what they collect, et cetera. I would imagine there's companies like yours that serve the paint manufacturing industry, and whatever machines make paint probably have unique protocols and data collection points and things like that. I'm making an assumption that your company's expertise is in the semiconductor and EMS kind of space, right? I would imagine that would be very important if I'm an EMS company, CM, so when I say I have a Fuji machine, you don't turn around and go, what's a Fuji, right? So are there players in your field that try to say, they're good at everything, and then, or are they very siloed, just organically?
Yeah. No, it's a really good point you're touching on. Yeah, there's a lot of companies that are repurposing, thinking, we did it on a paint shop, connecting a paint machine. We can connect to something else. Yeah, they're out there. There's a lot of vaporware sales. So you're hitting on it. The vendor needs to know your industry intimately. They really need to understand the pain points. Like, we can sit there, and we say, printer, you need to track your stencil. How many times it was used? You need an alert, tell you to swap the thing out, because we know what the quality issues are going to be. And we know the data that can be all tied together, from serialized etch at a CTI laser through air shower, AOI, AXI, mount your board, doesn't matter. We see the data, understand the inventory side, these things, all the way out to final test, functional test, and that. And there's a lot of companies that actually, created a solution, IoT, and they collect only, they have a little box that attached to your machine. It'll pick up vibrations and sensor data, put it off, and then they capture a bit of market share. And now they're like, okay, we can start collecting all this other data. And it turns out they have no idea what ICT data structures are, functional tests.
Right.
What is an STDF file? It's funny, but they will tell you, oh no, we're in the factory floor. So for an end customer, asking these questions. Okay, tell me
Number one, are you in my space, right? Do you recognize these brand names? That's probably the first qualifying question, right? Am I talking to a company that is familiar with what I use and what I buy and what's on my factory floor, right?
I've got a really egregious example for you. We just ran into this. So I love data, right? Data, and getting in there and looking at all this SMT data. Turns out, like, holy cow, we could actually push this to an ERP system like Oracle, SAP, where nobody has to manually enter anything anymore. And we did. So we did an integration with SAP. We got multiple with Oracle. I don't even care if you work using QuickBooks or your own custom spreadsheet. We'll push the data to it, and it will be accurate in real time. So now we're doing a lot more of these integrations. And one of the medical device customers we have, an Oracle team came in and they were going to sign up with them. And this Oracle team was like, oh yeah, ERP, yeah, we're great. So even in the ERP world, they say, well, we've done accounting ERP for all different companies, and yeah, we can do this no problem for this medical device, where they're using a silicon photonics chip as a baseline product. They've got consumables, a whole diagnostic system. Turns out this ERP vendor, they came out of the mattress business. Like, and that process got gummed up, and that is just, it dragged out because they did not understand the customer. But, buyer beware, it was one of the most egregious examples. Anyway, so, yep.
Interesting. We talk about how your customers vet companies like yours and others. One thing I've learned after 31 years in business is we select our customers just as much, if not more, than our customers select us. If we select the wrong customer, it's not going to be a pleasant experience for either of us, and both of us are going to be disgruntled. How does your company, how do you and your team go about making sure you're working with the right customer, that it's a good fit? Is there a process of, without getting into anything proprietary, obviously, but is there a process you go through to interview customers, kind of a discovery call, and to ensure that you're both you both have the same goals in mind?
Yeah, this is great. This is, this talks to about, I think the other part of this, so I'll answer that, but it's great because the answer also touches on how, our industry here, especially in North America, has to kind of move, I think still has to move a little bit faster in this, but become data-centric. For me, the main thing is that we see buy-in, that data will start improving things. We also see, another thing is that that they're willing to lean on us for guidance of good practices, best practices as well. But definitely data-centric mindset, and you have to have buy-in at the whole level, all the way up. If you don't, then you're gonna run into, you don't want to have, for me, it's like you don't want to have deployment issues. You need buy-in at the top, and they need to make sure everybody's on board that we're going to automate and we're going to drive data and we're going to become a data-centric company. You really have to see that right up front. So for me, vetting a customer, the other one is churn too. You get buy-in, and if there's a lot of churn, especially at a critical manager layer, if you've got a revolving door of production managers going in and out, it's going to be, that's a sign that it doesn't matter what the top says, they're going to lose the momentum to execute on this. And
you're not going to get traction. You're not going to get a lot of progress, right? Because you have to keep, it's like quite literally a broken vinyl record. It's just going to skip. And that's kind of our experience as well. You talked earlier about cloud-based. The advantage of the cloud is it can store almost infinitely more data than you would want to store. Factories don't generally have data centers, in their factory. Data centers, Amazon Web Services, all that stuff, they're in these nondescript, secret locations, bomb-proof, with backup generators, and they have multiple, backups throughout the country. Very kind of spooky cloak and dagger, for security reasons. But speaking of security, if I was a contract manufacturer, an OEM, and I was like ITAR listed, my experience with companies that are ITAR and similar types of protocols, security protocols, is, nothing can be connected. We have to, when we ship our equipment out, our equipment is operated by PCs, quite literally PCs, and we have to remove all the drivers, the Wi-Fi drivers and things like that. We have to put connectors with locks on them into the Ethernet ports and USB ports and things like that. I mean, they're dorky little locks. I mean, they're just plastic. They can be broken off, but at least someone would have to make an effort. It wouldn't accidentally just stick a USB drive in and download data. What are the options for someone like that who is very concerned about security and they're under regulation and scrutiny? Is there an alternative to a cloud model that can do all of that number crunching and storage of that data in-house if they can't connect to a cloud?
Absolutely. Yeah. It's just kind of having an IT person that kind of knows their good basics around it, right? So you can have all that machine on a network that's its own subnet. It's just its own little Ethernet network, and it has a single switch that connects it to the next network. And you can control there which ports are open and which direction traffic can move in. So you could actually have an MES or IoT data system sitting in your IT closet that is the only thing that's talking to that network. So the machines run, and you can collect the data from there, and you do it on an HTTP basis. Like, you don't push binary files, where something nefarious could be embedded. So there's no interchange. So very simple, but it's a drawbridge mode. You raise the bridge, nothing's moving in and out, or there's only one key to go in and out. Security is a big thing. Ransomware is huge. Unfortunately, it's just rampant everywhere. And it's always about weak infrastructure. Simple approaches. This is before I even created Intraratio. I would have a box with a database in it. I'd be collecting data, and I'd have another box that's an exact copy of it. It's $2,000 server sitting there. And every time you did a change here, it replicated onto this one in real time. But this one had a different root level access user, even used a different admin name, just separated. Somebody came in and they hacked one machine. You see them, you just throw the machine away, bring the other one, connect to the network, continue running as normal. And that stood the test of time, these simple approaches.
I guess that philosophy is not if, but when you get hacked, when it happens. The chance of them luckily hacking two at the same time when they don't even know those two are in your building is fairly remote, if not impossible. So prepare for the hack and have a backup.
Yeah, cloud is great for this. I just touching on the cloud thing. The audience, this should definitely resonate with many of them. Cloud is expensive, actually, if you don't do it right. It can be one of the biggest expenses you'll ever have. Your IT budget will blow up. Amazon is going to nail you for I/O, data pushing and pulling. It's going to nail you for RAM, adding to it. But that really gets you on the data side. So what you want to do is use cloud in a manufacturing environment. You don't want to run heavy analytics out there in the cloud.
Right.
The reason why a lot of vendors will push you to that is because it's easy for them to write crap software. I'll just be honest, right? It'll easy for them to test, right? They're like, oh, this report is now taking an hour. Okay, throw more CPUs at it, add more RAM. The customer is going to pay for it, and now it'll run faster. I cannot stand badly written code, like for myself. Like, I come out of the days, some of the first things I ever wrote was embedded software. I mean, we talk about memory limitations. I had 1 meg to stuff everything this controller needed to do it, so I'd write really compact, bulletproof code. Anyway, that's where I see cloud get abused. Cloud definitely has huge benefits, but in terms of manufacturing data setting, it can be very expensive. $4,000 server can service transactions off a couple high volume SMT lines. It'd be amazing how much data you can do off a $4,000 Dell machine off the rack. When that's capturing data, now have it copy it out and replicate it out to the cloud or the back end. So very simple technologies today, open source. You can Google it. It's called MariaDB replication, MySQL replication. You bring up a simple MySQL database. You can turn on this replication. You can have another machine out in the cloud. And every time there's a transaction on it, it's copied out there as well. Your factory blows up. Somebody ransomwares your primary machine. Throw it away. Pull a copy down from the cloud. You're off and running again.
Right.
It takes maybe an hour, 2 hours to recover.
Sure. And not $150,000 or $1 million in ransomware.
Yep.
Which the FBI will tell you not to pay, but they'll show you how to pay it. Right.
It's brutal. Yeah. Just as an example, we had a IT guy, a great IT guy we're working with at Cisco, customers, and there was a big push for them to migrate a bunch of their engineering servers and data servers off to the cloud. And he did the math. They had 120 servers to move off, and it cost them about $70,000 a year to operate them. So they operated the cost on that. The cloud model for Amazon, when they finally dug into it, was going to cost them $200,000 a month when they were fully up and running, just on the data IO. So you got to be careful. It's trade-offs, but great for just pushing data out and storing it. You can do glacial storage. Anyway, just want to put that out there. It's one of the things I like doing as a vendor. It's not the sales. The sales process is great, absolutely driving revenue, but I love to, share just these key tips and tricks to optimize operations and don't blow up the budget, and, kind of just help avoid the bogeys.
So you say you love data, and it sounds like you also enjoy writing code. So here's a code question for you. This is kind of off topic, but tabs or spaces?
Tabs all the way along.
Okay.
You mean for inline indentation?
Yeah.
Oh, absolutely tabs.
Evidently, in the code world, people argue about that personal style, and I don't know why. I've done, I don't write code anymore. I used to write. When we first started the company, I couldn't afford anyone to write the code, so I wrote the code. I'm a total hack. You would hate my software. I would drive you crazy because I had REM statements everywhere, leaving breadcrumbs, so I remembered what I was thinking when I wrote stuff.
It's the best thing, actually. Honestly, that is some of the best practices. Now, my guys, they would, I am 100% on that. But by the way, my team is much better than I am. I mean, the guys, even high school students come out, some of the skills they get these days. I mean, honestly, in the SMT world, you walk in a production line and there's a couple operators. Yeah, or new techs, they just come out of college. Not even high school, and they can write great little Python scripts. They can automate. Yeah. Sometimes it's like, hey, don't jump on a vendor like us to come in and solve your problem. You can really work that internally initially.
I'm a big believer that in school, in elementary school, reading, writing, arithmetic, coding. We need to teach coding. Not for the goal of turning them into a coder professionally in their career as an adult, but I think learning to write code, which I learned to write code when I was in high school, and that was in the 70s, with a phone modem to the mainframe at the school district and a teletype machine, not even a screen, a teletype machine. And but it taught me to think analytically. It taught me to think, because life is full of if, then, else statements, right? That's life. And it really helped me problem solve by learning to write code. And I think children would benefit from that as in terms of a life skill, just knowing how code works. We talked about, I used to write all our code in the early days, and then eventually we would get people who could write code. And I remember once looking through the code years later, some old code, some legacy code that we're not using anymore. And for some reason, I was looking through it, and one of the REM statements from the programmer who was the coder who was writing it was, "This is the way Mike wanted me to write it. I don't agree." But Mike insisted, and
I love this. I love those little things. I've had found code that I wrote like 10 years ago that said, if you remove this, you're creating a security hole. At this point, I would choose a different career. Thank you.
Yeah, little breadcrumbs for the next generation.
Yeah. But there's so many. There's kids learning today. It's great. I mean, high school, college. There's a lot of basic boot camp courses kids are jumping into. It's pretty amazing. So if a company's not data centric now, watch out. Some of your staff that you're hiring on, they're going to know their way around a computer and a good script and a program.
That's great. There's a lot of buzz right now about artificial intelligence. We mentioned that earlier, particularly with the modern headlines on ChatGPT and all that kind of stuff. How has AI, real AI, not bogus marketing AI, how has AI made its way into data analysis? And do you have any examples of that?
Yeah, I'm really excited about some of the applications, and I like to bring it down to machine learning. AI has got all these different categories, and so using the word AI, people think like full autonomous. Not there, not even really close. And I say close as we may be 97% there, but that 3% to really shift, that's a quantum leap that's got to happen in my mind. There's a lot of fluff around it. At the end of the day, AI has really shifted things from the machine learning side of it, where you can create these models that can sift through massive amounts of data and pull out insights. What you're seeing on ChatGPT and all these other things, it's just how these things can go off the rails. A great example is machine learning algorithms for facial recognition and some other signals done by the Florida police department. So one of the enforcement groups there was written by their own group. They brought in technology experts and they built it up. And what they found, it started running this, and they're like, we got great results. We were able to pick out somebody that's potentially going to do a crime before they do the crime, sort of that kind of dark level. And then what they found out was it was biased, because the piece behind it, helping these technologies developer, were helping them drive the input into these systems to train these algorithms, and these biases are there. So I think that's something that needs to be hammered home across the industry. Luckily, in manufacturing, we can deal with some very deterministic stuff, which is great. So obviously AOI, AXI is great. We have working machine learning models. We can actually identify an outlier, detect it anywhere on the production line at any time. Working on that, and super fun, and I love it. Exciting because, talking about on market shift, we deploy tools like that in our industry here. We are moving the needle. We are not an outsourced CM on the other side of the world throwing 20 people at a one product line, and all they're doing all day is looking for problems. We can solve those problems with data. But it's really machine learning, and it's really shifting it. There's companies that got, the cost of entry for automated visual inspection. There's a group out of Berkeley. They've got a software solution. You could use a basic webcam and place it over a table and move product underneath it, and it'll start to detect the anomalies for you after an hour of training.
A webcam?
Yeah, basic, simple cameras.
Wow.
Yeah, this advances, and great machine learning tuning. Last thing I'll say on that is I'm empowered by the fact that this is open source. We are sharing it. You can go and find it if you really want to roll up your sleeves and dig in there, and you've kind of got your head around some decent mathematics. It's not that far-fetched. It's very accessible, and that's a key thing to keep pushing in the industry. So it's not locked up technologies, but machine learning is definitely moving the needle in terms of just giving us more of our life back. It's not replacing us. It's giving me more time as an engineer to sit back and really solve design engineering problems, business problems. We leverage these tools for it. So anyway,
You talked earlier about all the time you get back. In your case, you used it to meditate and work out. I don't think too many manufacturing companies are going to open up a gym and a meditation center, a yoga studio or something, and have their employees do that. They'll find something more profitable for their staff to do. But all of that leads to efficiency. All of that leads to competitiveness. With all the supply chain stuff our industry's been through, with the logistical, the shipping containers, stuck out in the ocean, for a month or more, a lot of that is getting better. And unfortunately, what we learn from history is we learn nothing from history. But during those times, just, in the last year or so many companies are talking about, reshoring or nearshoring and things like that. Countries that we moved out of now all of a sudden look really attractive, because the alternative is even worse. So I think hopefully this was a significant enough disruption that companies are making longer-term commitments to where it makes sense to bring certain things back in-house. And in order to remain competitive, because obviously consumers are a fickle bunch, Amazon and Walmart have effectively driven down the cost of almost every consumer good to the point where I have no idea how, after it goes through the entire supply chain, how anyone can make any money on it, but obviously they do. But I think the way we're going to get to that point where we can bring manufacturing back home or near home, or at least to an area that's less volatile and more stable and logistically logical, near us, so we don't have to ship 8,000 miles, for a $20 part.
Climate, less fuel. less
Yeah,
environmental damage.
it's going to have to, yes, environmental, all that stuff. I think the way to do it is we just really need to become, hyper efficient, and we've done it in many. The equipment that is made now provides a great deal of efficiency over older equipment, over manual systems, and now, I remember that back in the day when my company was young, our profits were low, and we'd go through the chart of accounts and we'd look at all of our expenses and we'd go, oh, here it is, and we'd go through and we'd wipe 30% off the cost of doing business. Great. And then, then we'd go through it again, maybe a year later, and we go, oh, there's another 10% we can take off. And then we go through it again a while later, and then we found another 3% we could take off. And every time you go through that, you find more opportunities for efficiency and optimization. And I think what your technology is doing is it's taking an area that was never reviewed and making that area way more efficient. It's the gaps between the equipment that you're able to optimize. And we were doing equipment by equipment by equipment. Now we're doing the entire process, looking at it holistically and kind of for the first time, and finding great opportunities for efficiency. I think it's it's kind of a pioneering opportunity to increase efficiency and optimization that we've never really looked at in the way we're looking at it now before.
Thanks. That's a great way to bound it. Yeah. I never thought of it as pioneering. I'm still looking at it from a pure engineering perspective, but no, absolutely.
The application is quite pioneering, I think. Obviously, the technology, some of the technology is pioneering, but it's the application of that technology that, to me, is quite evolutionary. Maybe not revolutionary, because we've done it in other areas, but to look at the entire process and with the goal of accuracy and traceability and efficiency and optimization is I'm not aware of that being done before. There were older total methods like the Toyota manufacturing principle, and all that revolutionized one industry. But even that, had we not progressed from that, then car manufacturers by today's standards would be very inefficient, right? Even though that was a revolutionary approach to manufacturing at the time, we learned a lot from it. As American car companies learned a lot from it. But even that wasn't enough. We're way more efficient today since the Toyota manufacturing principles first were introduced. And we thought that was like the end all, right? Back in the day.
Yeah, we're you just tripped a thought. The key, I think the thing that's really happened is this fusion of physical manufacturing and the idea of web, the internet, how that's moved in, like a stack like ours where we sit on, is hyperscale. We can service a small line, you can service a global. Right now, we're sitting here and one of my customers can see a transaction happening in China within 300 to 400 milliseconds. In Illinois, sitting in Chicago, they can see exactly what's going on. They can see exactly what's happening in Mexico and Philippines in near real time like that. And that's just using web technology scale, the stuff that came out. I talk about the backbone of Amazon and Google. It's MySQL and some other technology, database technology that has permeated in and putting it in the right place. I think, understanding how manufacturing works and then taking this web scale, hyperscale technology that is cheap cheap in terms of no overhead on IT, can deploy really rapidly, immediate results, and bringing that in and mapping it to the manufacturing model. Yeah, it's exciting to see this fusion of that. And this is where a lot of kids, graduates coming out of school and college, they're all versed in web. They're versed in this. They're touching on it. One quick anecdote in terms of where this came for Intraratio. I never forget where things start. It always reminds me of just how fun the journey can be. I didn't land at this final concept, on a straight line, nobody does. Yeah. I happened to go to a conference. I was trying to build up a bigger data set, and I'm not I wasn't I didn't network very well, but somehow I mustered some guts, and I went, hit this thing, and it was a purely for database programming. It was MySQL conference, and I had no idea why I was there, and then I'm bouncing around, and then I just started asking some questions. The next thing you know, anyway, long story short, I'm having schnapps, shooting some Swedish schnapps with one of the original founders from Sweden of MySQL, this Monty Wadinius, and his whole crew, and he's connecting me with a bunch of people, and so put in mind, I'm an engineer, semiconductor guy, purely, and now I'm stuck in this with a bunch of these database guys, and the stuff they're talking about is amazing, and half the party was a new crew from this startup company that was just getting off the ground, and they're trying to figure out how to do the back end of LinkedIn. That's what it was in 2006, was the start of LinkedIn. And so these guys were actually talking to me about my data, and it was amazing, the synergy of like, I'm dealing with semiconductor manufacturing data. I'm trying to put in a database that's meant for web. And they're like saying, no, it's not just for web. Look at all these structures behind it. This thing will scale, work. Call us. Hey, here's a book. Here's some reference. That was sort of the thing that really moved the needle. So anyway, it's all kind of converging. It's great. This whole technology stack. We build the servers and the chips for the servers, right? We should be using the software that runs so well on these servers to help drive our innovation. So
we're pretty much out of time, but let me ask you just one final question that I'd like to ask most of my guests. Get out your crystal ball, Ryan, and where do you see your industry's future in the next several years?
Yeah, it looks great to me. I'm an eternal.
And this is going to be this is recorded, so we're going to play it back a few years from now and see how accurate you were. Right?
Awesome.
You heard it here. Yeah. There you go.
I see, as long as the nearshoring momentum continues, which I believe it absolutely will, I see with the government now behind us and the amount of money they've injected in it, and that opens up a whole bunch of other debate and stuff. Nonetheless, that is a major driver for innovation and growth in our industry. Mexico, so much stuff. North American Free Trade Agreement has really created a market, and now a massive market of interchange. And the various different countries have great expertise, it's software, hardware, natural resources out of Canada, to drive our innovation, for manufacturing here. And just, I see in the industry, it looks great. I mean, we're bringing on semiconductor fabs. Again, we're bringing in that tech here, and we can leverage data to really accelerate our capabilities and remove that labor discount that, makes it such an unequal market. Anyways, I see a lot of momentum, and if that keeps continuing, I think it's advanced tech, it's new technology, higher paying jobs, great opportunities, and I just see a lot of great growth ahead of us on that.
Excellent. Well, Ryan Gamble, founder, CEO, Intraratio, thank you so much for being my guest today. It's a fascinating conversation. I hope we can do it again, because I have a feeling we're not done. I still got piles of questions here. So maybe we'll have you back again, and we'll check in on your predictions, and we will ask many, many more questions.
Thanks today. More than happy to. Yeah, it's great questions. Yeah, this topic, and curious to see what other topics you want to dive into. But thank you so much for today.
Yeah, my pleasure. Well, that's another episode. Thanks for listening to or watching the Reliability Matters podcast. Our episodes have been downloaded more than 30,000 times. I remain ever grateful for your support and encouragement. Don't miss an episode. Subscribe to Reliability Matters on Apple Podcasts, Google Podcasts, Spotify, or on our newest channel, Amazon Music, or virtually wherever you get your podcasts. If you're watching this on YouTube, click the subscribe button and bell icon to be notified when new episodes are released. We release new episodes on the second and fourth Tuesday of each month. A special thanks to Circuit Assembly Magazine's PCB Chat at pcbchat.com and Ascendo Reliability at reliability.fm for syndicating this show. Thanks also for your questions and episode suggestions. Please keep them coming. Send comments and episode suggestions to Mike at mikekonrad.com. That's Konrad with a K. Once again, thanks for listening or watching. Until next time, stay safe, stay healthy, stay happy, and perhaps, most importantly, keep doing it right. And I'll see you again in 2 weeks.
Thanks for listening to the Reliability Matters podcast. Join us on the second and fourth Tuesday of each month for new episodes of Reliability Matters.